Lesson 8, Problem 2.6. A cast iron tube is used to support a compressive load. Knowing that E is equal to 69 GPa and the maximum allowable change in length is 0.025%. So determine the maximum normal stress in the tube and the minimum wall thickness for a load of 7.2 kN if the outside diameter of the tube is 50 mm. So first is we need to know what are the given values in this problem. The given values are the elastic modulus or E, which is equal to 69 GPa or 69 times 10 to the power of 9 PA. And then next one is the strain, which is equal to 0.025%. And then load P, which is equal to 7.2 kilonewton or 7,200 Newton. And lastly, the outside diameter DO, which is equal to 50 mm. So solution A. So in finding the stress, we need to use the formula stress is equal to elastic modulus times strain. So we already have the values for E and the strain, so we can just substitute. So stress is equal to 69 times 10 to the power of 9 times 0.00025, which is equal to 17.25 megapascal. And then the next one for the solution B, since we already have the value for stress, which is the 17.25 MPa, we can use the this formula. The stress is equal to load over area. We have the values for stress and load. So what we need to find is the value for area. So area is equal to P over stress. And then we need to substitute the given values. So A is equal to 7,200 over
1725000,
which is equal to 417 times 417.39 mm squared. So this A is the area of the hollow cylinder. The area of the hollow cylinder has the equation of pi over 4 times dO squared minus di squared. So in finding the minimum wall thickness, we need to first identify the value of di. And since we already have the value of dO and A, we can just substitute it to the formula. So 417.39 is equal to pi over 4 times 50 squared minus di squared. And then we need to isolate di squared. So di squared is equal to 50 squared minus 4 times 417.39 over pi. And then which is equal to di squared is equal to 1968.56 mm squared. Since di is still in squared, so we need to apply square root for both sides. So by applying square root, di is equal to 44.368 mm. So we already have acquired the value of di. So we can use the formula for the minimum wall thickness, which is equal to 1/2 dO minus di. And then just substitute the given values. So we can get T is equal to 1/2 times 50 minus 44.368, which is equal to 2.82 mm. So the value for the maximum normal stress is equal to 17.25 MPa, and the minimum wall thickness is equal to 2.82 mm.